Assalamu alaikum guys. Inshallah, today I'm gonna explain how to solve this problem regarding the best first search, branch and bound. So the problem is about how to use the best first branch and bound to solve the TSP problem. And if you recall the TSP problem or traveling salesman problem, it's about multiple cities. It's about first about a salesman who wants to visit multiple cities, and he is looking for the path that costs the least, so that he have a circular round that ends on the point that is started from. So if he started, for example, if he started from the city number 1 and followed by 2, 3, 4, 5, he has to go back to 1 again. And he's looking for the path with the minimum path. There are multiple ways to solve such a problem, but every one of the solution, of course, will lead us to a higher with higher what is it called? With going exponentially with higher complexity, basically high complexity. Anyway, so what we talked so far is solving this problem using two methods. The first one is dynamic programming, and the other one is about branch and bound. And for branch and bound, we have kind of an improvement for traversing the tree, which is the best first approach. Okay, so now we can start solving such a problem. So normally in such a problem, the professor will give you something like an adjacency matrix, and from this adjacency matrix you can get the cost from going from city 1 to city 1 or city 2 or city 3 or 4 or 5. Okay, like exactly in the previous problem, there was this adjacency matrix that say that from going from city 1 to city 1 you have infinity or 0, because there is no loop going from city 1 to city 1 itself. There is no loop. And from going from city 1 to city 2, it costs about 14. So like this, and so on. So starting this problem would be by building this matrix, this adjacency matrix. And how we do it is it's basically, we have to get how many cities that we have here. We have 1, 2, 3, 4, 5, 6, 7, 8 cities. I can just note them by numbers: 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I will make this one a little bit bigger. And this one as well. Okay, so now we can start. Of course, going from 1 to 1 is infinity. Going from 2 to 2 as well is infinity. 3 to 3 is infinity. 4 to 4 is infinity. 5 to 5 is infinity. 6 to 6 is infinity. 7 to 7 as well infinity. And 8 by 8 is infinity. Going from 8 to 8. Maybe I have to get this one a little bit lower. This is 7. Then the way that we complete that matrix with is just by identifying, for example, from one getting from 1 to 2 is 5, so from 1 to 2 is 5, from 1 to 3 is 8, from 1 there is no pass from 1 to anything else, thus the rest will be just infinity. Then from 2, let's see node 2. 2 has a path to 5, which is 4. So 2 to 5 is 4, and 2 to 3 is 4 as well. And 2 does not have any other path, thus the rest is just infinity. We will keep doing that until we finish all these numbers. I will finish them offline and then I will come back again. So now after I have finished filling the whole table, this is what I came up with, which is better than what I was doing. Now it will be easier because now I have my adjacency matrix, and now I'll just have to apply my branch and bound style. So what we will start with is just making something like this and getting the lowest from each row. For example, from this row, the lowest number is 5. From this row, the lowest number is 4. From this one, it's 2. From 1, this is 8. This one is 1. This one is 2, 3, and 4. Okay, so this is the lowest number in each row. Now what we have to do is just sum up all of these numbers to get the minimum theoretically, the minimum path that I cannot get something below that number. For example, if we sum up all of these numbers, it will be, those are 4. I have another 4, I have another 4, 4, 4. So this is 12. Now I have 3 and 7. This is 10. Then I have 5 and 1, which is 6. And I don't have anything else. So this is 22 plus 6, which is 28. So 28 is the least, is the minimum cost that I cannot go beyond, that I cannot go beyond. Of course, it doesn't have to be true. It doesn't have to be true that the minimum path that you will get at the end is 28, because this is just a theoretical bound. It's not the actual bound or not the actual cost. So this is the 28 that I have. Now I will be using the 28 for the branch and bound. Okay, so now I have 8 cities. I have to go from city 1 to 2 or 2 to 1, whatever order that I want. From any city to other city, it doesn't matter. So now I will assume that I will start from city number 1, and I will just start the route with any order. So if I start from the first city, after that I can go to city number 2, 3 or 4, 5, 6, or city number 7 or city number 8. Okay. Now what do I have to do right now is just It's just getting the path from 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, and so on. How to do that? I will use this method. Of course, I will just have to remove the dashes. I'll just remove them all and rewrite them again. 4, 2, 4, 2, 7, 1, 2, 3, 4. Okay, so now what I will be doing is checking from 1 to 2. From 1 to 2, I have here 5, and it's already 5. So that means that the whole journey till this point will cost 28. Now from 1 to 3, 1 to 3, 1 to 3 is infinity. Since 1 to 3 is infinity, that means that replacing this 5 by infinity will give me an infinity cost. That means that the cost here will be infinity. Now from 1 to 4, from 1 to 4 it's infinity as well. So the path from 1 to 4 is infinity. The path from 1 to 5 is already infinity. 1 to 6 is infinity, infinity, infinity. Okay, that means that if I am willing to start, I will just have to start from 1 to 2, because this is the lowest among others. Now for the second level, since I already have visited the second node, I can go after that to node number 3, 4, 5, 6, 7, or 8, right? Now I have to see, now I need to calculate the distance between 2 to 3, 2 to 4, 2 to 4, 2 to 5, 2 to 6, and so on. If I look here in the table, I will find that from 2 to 3, it is 4. From 2 to 3, it is 4. 2 to 3, it is 4, which is the same as this one. That means that till now I'm having 28 as my path. From 2 to 4, 2 to 4 is infinity. That means this one is infinity. 2 to 5, 2 to 5 is already 4 as well. That means I will be having 28. From 2 to 6, from 2 to 6 is infinity. From 2 to 7 is infinity. And here is infinity. Now I will go to the lowest only. I will pick this one. Since I don't have anything below 28, I will just go with this one, with the 3. Now I will start exploring. Since I'm taking this path, 1, 2, 3, now I can go to 4, or 5, 6, or 7, or 8. Okay, now I have to calculate the distance between 3 to 4, 3 to 5, 3 to 6, 3 to 7, 3 to 8. Okay, now I will kind of just repaste it here again so that I can look faster. Okay, now from 3 to 4, 3 to 4, it's 2. And the minimum at this row was 2. That means I will not change anything yet. And that will be just 28 so far. Now from 3 to 5, from 3 to 5, it's infinity. This is infinity. Now from 3 to 6, 3 to 6 is already infinity as well. Now from 3 to 7, From 3 to 7, it's 5. However, the minimum at this row is 2. That means I will be adding, since the total here was 28, I will be adding 3 to that total so that I can compensate for the 5. That means the minimum path at this path is 28 plus 3, which is 31. Okay, now, okay, so now from 3 to 8 is infinity as well. Okay, now, according to best first, I have to look up to see if I got better answers. Here I have 28, here I have 31, here I have another 28. So the order for this traversal would be, I have to explore this node first, this one first, then this one, then that one. Okay, this is the order for traversal, because this has a better result than this one, or a minimum bound in other language. Now, if I have already visited node 4, I will go for the rest, which is 5, 6, 7, and 8. Now I have to calculate the distance between 4 and 5. Between 4 and 5. So 4 and 5 is infinity. This is infinity. 4 to 6 is infinity as well. 4 to 7 infinity. And 4 to 8 is 7, which is the lowest among this whole row. So that means I will be keeping the 28 as it is. Now if I visit 8, I'll have to go to 5 or 6 or 7 again. Now from 8 to 5, from 8 to 5, it is 8 to 5. This is infinity. 8 to 6 is 5, which is not the minimum at the row. The minimum in the whole row was 4, but this one is 5. That means that I will increase 28 by 1, because the summation using 4 was 28. But now I have 5, so this one, the total summation should be 29, right? Now from 8 to 7, from 8 to 7 is 4, which is the normal one. So this is 28. Okay, since I'm using best first, I will go explore this one first. Now I'll be watching. From 7, I can go to 5 or 6. Now from 28 to from 7 to 5, 7 to 5, 7, 1, 2, 3, 4, 5. This is infinity. And from 7 to 6, 7 to 6, this is 8. So 8 was not the minimum at the row, because minimum at the row is 3. That means that I will have to add 8 minus 3, which is 5, to the 28. So this one is 28 plus 5. 28 plus 5, this is 33. So this is 33. Now now I can look back to not now, but I will just خلاص, this is cancelled because it's infinity. Now only this one is valid till this point, and then to get the minimum path, I have to get back from 6 to node 1 again, because it's the node that I have started from. So I went from 1 to 2 to 3 to 4 to 8 to 7 to 6, and now I have to go back to 1. From 6 to 1, I have to see it here. From 6 to 1, I see infinity, so that the cost from this whole path will be infinity, which is unacceptable. So I will not consider this as a solution, and I'll have to explore other nodes as well. So I will go and see the order for the number of levels and the minimum cost. So this one has the lowest bound, the 28. So I'll have to bound to it and then watch the results. Now from 5, I can go to 3, to 4, to 6, to 7, to 8. Now I can see from 5 to 3, it is infinity. From 5 to 4, 5 to 4 is infinity. From 5 to 6, infinity. From 5 to 7, it's infinity and infinity and infinity. Thus, this one is not acceptable. Now I have two options right now, either this 29 or this 31. I will, according to best first, I will be exploring this one first, which is 29. So after this one, I can go to 7 or I can go to 5. So now I have to calculate from 6 to 7. From 6 to 7, it's infinity. From 6 to 7, it's infinity. And from 6 to 5, it is 2. It is 2, which was the lowest in the whole row. Thus, I will be keeping the 29 here. And then I have to go back from 5 to 1 again. So that I have to see from 5 to 1, it is 1, and this is the lowest in the whole row. That means that this path is valid and can cost me 29. Okay, so that means I have finished this problem with a bound of 29 only. That means it's correct. And now I do not have to visit this one because it's already bigger than the bound I have. If this one was, for example, was 36 and this one is 31, I would have explored this one. But since we already got a lower answer, خلاص, that means this is my final answer, and the last path, or my minimum path, will be 1, 2, 3, 4, 1, 2, 3, 4, 8, 7, 5, and back to 1. So that's it. Maybe I have to do a simulation to just verify the answer of it.